There's a strong positive correlation over time between the salaries of teachers and the amount of liquor sold. Does that mean the guardians of our youth are squandering their new wealth on whiskey? Of course not. General prosperity and inflation are behind both increases. So the cartoon interpretation of the correlation is silly. But the correlation itself is perfectly real. The point is that you can't automatically interpret a strong correlation as a cause and effect relationship. We all have a sense of what causation means in physical terms. Swinging this ball obviously causes this one to move when they collide. But like a lot of things that seem perfectly clear, causation can get slippery when you try to pin it down. Our main point in this program is that causation is only one of many possible explanations for an observed association. We'll see that an association between two variables can also be due to a common cause, a confounding factor, or just coincidence. We'll learn about Simpson's paradox, a striking example of how a hidden variable can actually fool you about an association. And we'll see how convincing evidence for causation can be gathered. Let's begin by getting a feel for some unexpected associations and for some of the underlying difficulties in explaining them.
It's a little-known bit of beach trivia that ice cream sales are positively associated with the number of drownings. One possible explanation is you should have listened to your mother. Eating before you swim could have grave consequences. Another, more ghoulish explanation is that people on the beach gobble up all the ice cream in sight to console themselves when someone drowns. But there's a better explanation. Both ice cream sales and drownings are showing a common response to a third factor: temperature. On a hot day, more people go to the beach, more ice cream is sold, and more people drown, simply because there are more swimmers. In 1974, Congress lowered the national speed limit to 55 miles per hour. The following year, traffic fatalities decreased by 20%. Can we say that lower speeds reduced the number of deaths? The change in the national speed limit was a result of the Mideast oil embargo. But the gas shortage also meant that people were not driving as often or as far as they had before. These factors were confounded or tangled up with the lower speed limit. So it's impossible to distinguish just one cause of reduced highway carnage. The population of Louisiana has been increasing steadily since 1970. At the same time, the state's land mass is decreasing at the rate of 17.5 square miles a year. Is the extra weight causing the state to sink into oblivion? Hardly. The association is purely coincidental. People move for job opportunities and other personal reasons. Shore areas sink because of geological processes. The two have nothing to do with each other.
In all of these examples, we could have calculated strong correlations, but judging causation requires clear thinking as well as computing. Now, a strong association does invite investigation, but before reaching a verdict, we have to look for hidden factors, factors which may have an important effect on the response variable we're studying. We might not think of looking for them when we're listing possible explanatory variables. They're sort of lurking in the background, and that's what we call them, lurking variables. To show you just how dramatic the impact of